Okay. With number 3, I personally think this one was the most tricky in accordance to getting the right functions and then factorizing and not making small mistakes. So before we do it, let me quickly summarize. You can either get a normal sin and a normal cos. Then you divide with cos. The one will become tan, the other cos will disappear. Or you can have two functions where the one is a square and the other one is not a square. Okay? But the functions are the same. So I've got cos squared and cos squared. Then it means it's factorization. Okay? Okay, that means I'm going to factorize. Right? When I have a square, that means I've got two answers. Always. Square means two answers. And when it's the same, it's sin and sin squared or cos and cos squared, then it's fine. Just get everything on one side and factorize. And then the third situation, like in this case, is I have a sin squared, so the one is a square and the other one is not, but then the functions also differ. Then you're going to use an identity. Because sin squared is 1 minus cos squared. So you put it in. But you'll see I've underlined there. Because that's the big trick, that this 2 must now be in front of these brackets. When you substitute sin squared with 1 minus cos squared. And then that 2 has to multiply with both of them to look like that. And then only can you get everything on one side in order for us to factorize the quadratic trinomial. You can use the K method to factorize. But as I've said before, you don't use cos to factorize. You only use this coefficient and this constant. So whether it says cos or sin or k or whatever, it really doesn't make a difference. So this 2 cos squared theta can only be made up with 2 cos and 2 cos. Oh, not 2 cos and 2 cos, 2 cos and cos. So that's going to be the first terms in my bracket. The only way that I can get 2 is 1 and 2. Now all you have to think about is the order, where the 2 has to be and where the signs have to be. So I need to get a number 3 in the middle. Okay? So therefore, when I look at 2 and 2, I know it's going to be 2 times 2 to give me 4, and 1 times 1 to give me 1. And 4 minus 1 will give me 3. So therefore, I want the 2, this 2, to multiply with the 2. And when it has to multiply, it has to be in the other bracket. So that's why I put it there. Then this one is 1. Now I make a decision on the signs. I want it to be positive 3. So therefore, I want it to be positive 4 minus 1. Not 1 minus 4. Do you understand? Okay. So therefore, this one needs to be positive. So that 2 cos times 2 will be positive 4 cos. And I put the negative there so that this 2, when they multiply, remember it's the 2 middle terms, ne? It will give me negative 1 cos theta. So I'll have 4 cos minus 1 cos. And that will give me the 3 cos. These 2 multiplied, it gives me negative 2. These 2 multiplied, they give me 2 cos squared theta. Do you understand that? Okay. So now I've got my 2 answers. And then immediately, without even checking it on my calculator, I say that this one is not applicable. Because it's smaller than negative 1. If it's smaller than negative 1 or greater than 1 when it's sin or cos, it won't work. This one can work. Shift cos a half, I get an answer of 60 degrees. It is positive, so it's in the first quadrant and in the fourth quadrant. Then I get those two answers, K an element of Z. Now with this one, they specified that they want the answers between negative 180 and positive 180. If they wanted the answers between 0 and 360, you just take these two answers. But when it's less than 0 or greater than 360, then you're going to have to substitute into K. And in this case it was. From negative 180 to positive 180. So when I substitute negative 1 in there, it gives me negative 300. Won't work. If I substitute in 0, I get 60. That one is fine. If I substitute in 1, it will be 420. It's too big. Then I go to the other equation. If I substitute in negative 1, it gives me negative 60, which is in the restriction. If I substitute in 0, it will give me 300. That's too big. So the only two answers I have are those two. But then I just want you to make a point of it, to write them from small to big. Okay. And let me just explain the brackets to you. If you were to use a round bracket, for example, if I give you an answer and I say theta is an element from 0 to 180, round brackets. That means it's all the values between 0 and 180. Like for example, if we go back to that, like this, it's from 0 to 360. It's not 0 and 360. Do you understand? If it was a block bracket, all it would do is it would include 0 and it would include 360. But it's still from here to here. So if I were to put this in a round bracket, you would say the answer is from negative 60 to 60. And that's not true, no? So when I want to specify the value, I put a curly bracket. Okay, if you curls, you see I struggle making the curls. But it just mustn't be a straight line or a, you know what I mean. Just give it something. Then you're showing it's the specific values. Okay. You all understand? Let's go to number 4. Okay, number 4. Although I really put in my best effort in grade 8 to teach you fractions, we all hate fractions. Eh? So how do I get rid of a fraction? I multiply with the denominator. The whole denominator and everything. So this one cancels out here and then it just goes to the other side and then it looks like that. Okay. So at this point it might still look a bit intimidating. But remember I said we have 3 situations. Normal sin and cos, or cos and cos where 1 is squared, or sin and cos and 1 where one of them is squared. Okay. For all of them we have a solution. This is still just sin and cos. There's just more of them. So all you're going to do is you divide each one of them with cos. Right? So this one becomes tan, this one becomes 1, this one becomes tan, this one becomes 1. And then it looks like that. 2 tan theta minus 1 equal to tan theta plus 1. So what I wrote here at the top, it's like an algebra sum. 2x minus 1 equal to x plus 1. Do you understand that? So if we did the algebra sum, the x would go over 2x minus x is just x. And then the negative 1 has to go over, it will come plus 1, so it will be 1 plus 1 is 2. And that's how I end up getting tan theta equal to 2. And now it's just a normal sum, ne? Shift tan 2, 63,434. It's positive, so it's in the first quadrant, you use it as it is, and in the third quadrant you add to 180, then you get the answer, K, an element of Z. They asked for the answers between 0 and 360 degrees. I'm not even going to substitute into K, because this 0 to 360 is the normal cast diagram answers. So it's just these two. Curly bracket. They're getting better, you see. It's fine if you did it. If I were you, I would just in the next step write it clearly to indicate your answers. So you're supposed to be get all your marks, but we don't know who's marking your paper at the end of grade 12. So for that case, just for safety, I would indicate in the end. So use your table to help you, and then you just summarize your answer. Okay. Alright, next up, the last one was easy, ne? Cos and sin, plain cos, plain sin. I took over the cos to become negative, and then I divided with cos, and then my answer is tan theta equal to negative 3. Shift tan 3, get the answer 71,565, and then it's in the second and in the fourth quadrant because of the negative, and then you get your two answers, k element of z. I just wanted the general solution there. Okay, now I quickly, before we go on, there are some other things that I want to show you, the last work. Ne? We said we have already spoken about the undefined values. Ne? But before we get to that, I just quickly want to show you something here. So I'm afraid to ask because I asked the other classes and then I got very upset. But let me just get upset again. Who of you have worked out the practice test? Oh, good job. Are you lying on Tatile now? You see all the rest are putting their hands up, so you put up your hand. She's like, don't lie, man. Okay, if you did it, you might have come across the general solution sum in this one. So what it looks like is they've given it to you as 2 sin x cos x minus cos square x equal to 0. Alright, now the problem with this sum, and that's why I just quickly want to talk to you about it. You must just remember to stick to the plans, just keep trying the same thing over and over again. Okay, or not the same thing, the different things, but don't do something fun. Right. So what we used to is we used to either having only cos and cos squared, or having sin and cos squared, then we would make that one 1 minus sin squared. Or we'd have just a sin and a cos, then we divide with cos. Then it would become tan. Okay. So in that case, it seems pretty fine. Right. But now, with all of the scenarios that I've said now, every time there's something else in this one. So in the previous classes we spoke about it and we made some plans, and some plans worked 100% and other plans only worked 50%. And I want to talk to you about that. So I said it at the beginning of the period as well, and I want to say it again. When you have a square, whether it's in algebra, geometry, trigonometry, wherever, it means two answers. Even if your one answer is sin theta equal to 2, that will give no answer. It still is a second answer. So you cannot just get one answer. Now I'm going to show you the situation where we only get one answer first. Okay, so this was one of the plans. The plan is to divide with cos square x. It's a brilliant plan. Okay, it's a good plan. Obviously you're dividing the 0 with cos square x as well, no? But 0 divided by anything is just 0. So what would happen here is this cos and that square would cancel out. Then I'd have sin over cos left. What is sin over cos? Tan. So I'd have 2 tan x remaining in that one. And in this one I would have minus 1. And then that's pretty easy, ne? Tan x equal to a half. Do you see how many answers I have? 1. How many answers must I have? 2. How do I know that? Because of the square. Okay. So brilliant plan, but you lose one of the answers. You only get half of the marks for this sum. Second plan. 2 sin x cos x minus cos square x equal to 0 is to take out something in common. Okay, do you see it? It is there. So when I take out the cos x, what I'm left with is 2 sin x minus cos x equal to 0. So my one answer is cos x equal to 0. My other answer is 2 sin x equal to cos x. And then I divide both with cos. And then I have 2 tan x equal to 1, which is tan x equal to half. So do you see how amazing this is? That using completely different methods, but we're doing it the right way, up to there we get the same answer. But because we cancelled out the square, we're losing one of the answers. Okay, we remember that. So make a point of it. Square means 2 answers. Alright. Let's get to the invalid values. I want to look at this one. I asked you to write down the example. No, we're just going to do it now. Okay, so I said for invalid, there are only 2 things. The first one is tan, and the second one is a 0 denominator. So it's not hard, and it's still general solution, nothing funny there. So when I look at this one, I immediately search for a tan, and I see there is a tan. Do you agree? So I'm going to start with it. The first one is theta equal to 90 degrees plus k times 180. Remember, the question states, for which values of theta will the function or the identity be invalid? So we can't draw a line through it. Because I'm saying if theta is 90 degrees plus k times 180, it will be invalid. Next up, any denominators. So there's the first one. 1 plus sin theta equal to 0. Sin theta equal to negative 1. Shift sin of 1 gives me an answer of 90 degrees. Cos diagram in the third and in the fourth quadrant. Show me with your hands what the sin graph looks like. Just from 0 to 360. Okay, so it starts in the middle, goes up, reaches 1. Goes down, cut 0 again. Negative 1, 0 again. How many times did I reach negative 1? Know that beforehand, because you are saving yourself time. If you don't know it beforehand, you are going to say theta equal to 180 degrees plus 90, which gives theta equal to 270 degrees plus k times 360. And then you would go and you would say, and also in the fourth quadrant, 360 degrees minus 90 degrees, theta equal to 270 degrees plus k times 360 degrees, k element of z. Do you see you've got the same answer? With sin, it happens for 1, only one place, 90 degrees, and negative 1, only one place, 270 degrees. Okay. Now, there's another denominator. Do you see it? Cos theta. You can do cos theta as well. But Why does tan have an asymptote? Why does tan have asymptotes? Huh? Can't hear. But why are they asymptotes? Why does it give you an invalid at 90 degrees and 270 degrees? Clear? What is tan actually? What is sin over cos called? What is something called if it's got something at the top and something at the bottom? It's got a fraction, so tan is a fraction. No? Tan has a denominator. What is the denominator? That's why it has asymptotes. Okay? Because cos is the denominator. So at 90 degrees, let me show you. I told you this when we did it, but you've forgotten. This is the cos graph. What is cos at 90 degrees? 0. That's why tan has an asymptote at 90 degrees. What is cos at 270? That's why tan has an asymptote at 270. And so I can go on. Okay? So do you realize, my lieve kinders, that once you have given tan's equation, you have given the values of a denominator, of course. So if I were to write cos now as well, I will do it. You can do it in the test. If I am to write cos theta equal to 0, shift cos of 0, I'd get an answer of 90 degrees. So I told you guys, you choose what, or 0 is positive or negative, we choose it positive. So it's going to be in the first quadrant and in the fourth quadrant. No, in the third quadrant. So the first one, theta equal to 90 degrees plus 300k times 360 degrees. And then the second one will be theta equal to 180 plus 90 degrees. And that's equal to, am I still on the board? No. 270 degrees plus k times 360 degrees, k element of z. Okay, ne? You agree with that? So it's 90 plus k360 and 270 plus k360. Now tell me, what is 90? This is now tan's equation. What's 90 plus 180? What's 90 plus nothing? 90. What's 90 plus 180? 270. So can you see all the values included in tan will be in cos? Because why is tan tan? Why does it have asymptotes? Because its denominator is cos. Does that make sense? But if you are not feeling comfortable with it, put in your cos. It's fine. We won't lose marks. Done? Okay. I quickly want to go through exercise 14 with you. You don't really even have to copy it, okay? If you understand this, it's fine. I just want to show you. So if you look at exercise 14, page 168. Number 1a, this is the question. So firstly, I'm scanning the identity to see if there's a tan. Remember, the question in a test is they give you this thing, then they'd say question 1, prove the identity. So you prove left side equal to right side. You remember those? Then the next question after that will be, for which values of theta will this identity be invalid? And then you're going to do what we are going to do. So I scan for a tan, I see there it is, I write it down. Then I scan for a denominator. Are there any denominators? I've already written down tan. No, don't be scared. There's nowhere that you can see a line with something at the bottom. You are correct. Believe in yourself. It's not a trick question. Was it too easy? Okay, you are done. That's the answer. You understand? Okay, that's how easy it is. They only count 2 or 3 marks, these questions. That's why I'm saying we're not going to spend a lot of time on it. B. Is there a tan? It must literally say T-A-N. It's not going to hide. Okay. It's not there. Can you see it? So we don't write it down. So you see tan doesn't have a sum. You learn that formula. 90 degrees plus k times 180. You see tan, you write that down. But the denominator one has got an equation that you're going to solve. So is there a denominator? Sharp, there is. You write down the whole denominator. Sin theta plus cos theta equal to 0. Okay? And now you just solve it. So I've got a sin and a cos. How do I get it to be one function? Divide by cos. Then it becomes tan equal to -1. Shift tan 1, 45 degrees. Second and fourth quadrant. Second quadrant, 135 plus k times 180. Fourth quadrant, 315 plus k times 180. K element of z. Does it make sense? I divided with cos here, ne? To get it to be tan theta equal to -1. I will show you C as well. Do you remember this identity when we did prove the identities? Then we put these two denominators next to each other, and then it was 1 minus sin, 1 plus sin, it became 1 minus sin squared, and 1 minus sin squared became cos squared at the bottom. And then what you need at the bottom, you multiplied at the top, ne? And that one you did there as well. Then there was a negative, it was brackets, you multiplied the negative in, and then it sorted itself out. Do you remember that one? This is the one where you had sin, I think it was sin over cos squared that you ended up with. Then the sin took that one cos to become tan. Remember that example that I showed you? It was 2a and 2b of that activity, where the sin takes one of the cos's and it becomes tan. And the other cos just stays at the bottom. Okay, first one. Do I see a tan? T-A-N. Write it down. Do I see a denominator? 1 minus sin x equal to 0. Take the 1 over, becomes plus 1. Shift sin 1 equal to 90 degrees. It's positive, so it's in the first quadrant. 90 plus k times 1, k times 360. Do you notice this one? Sin and 1. How many times does sin reach 1? Once at 90 degrees, so there's not another one. And 1 plus sin x equal to 0 is sin x equal to -1. That's negative. Do you remember sin and -1? Only happens once. 270. But if you do it formally, you get 90. It's negative. It's in the third quadrant. There it is. Fourth quadrant as well will give you 360 minus 90 is also 270 plus k times 360, k element of z. Okay, with that we are done for the test on Wednesday. I also showed the other two classes, one or two things. That's not in our textbook. It's not really in the syllabus. We wouldn't have seen an example like it. And I'm not going to put a question like that in the test of Wednesday. But in the years that I've taught grade 11, maybe I've seen this question twice, if it was that many times. So I want to show it to you, just so that you know. You can copy it. It's not hard. It's very easy. It's just because we haven't seen it, we don't know what to do. Okay, there are three sums that I want to show you. So this is still the trigonometric equations. It's not new work. So remember, with the trig equations, we want to get a function and we want to get a value, a constant number, so that we can press shift, the function, and then the number. Now, as you see here, we've got two functions. Okay. But with equations, you are allowed to use your calculator. So can you type tan 90 on your calculator? You can. So if you press tan 90 on your calculator, it gives you a math error because it's an asymptote. So there's no way that you can get tan 90. So this one will have no solution. So that can happen. But the reason I took this one is because if it was tan 45, then you type that in your calculator, you get 1. And then you just go on with the sum. Okay. So if that is one that you can type, you type it. In other words, it has no variable. The next one. We haven't seen one like this, no? I will tell you what the difference is. With all the ones that we did, we had the same angle here as we had there. So if it is sin x and cos x and tan x, then it's fine. But if it is sin x and cos y, can't do anything. Good. Because sin x over cos x is tan x. But sin x over cos y, that's nothing. Okay, different variables. So you can see here, what's in there is not the same. But when that happens, all you're going to do is you throw away the sin. Like with exponents. Remember exponents, when the bases are the same, you throw them away. Just continue with the exponents. Same type of thing here, you just throw it away. And that's like a grade 8 sum. Eh? 5x plus 30 equal to x. You take the x over, you get 4x equal to negative 30. And do you agree with me? Now we're going to divide with 4. That's obvious. But now I want to stop you. Do you remember when we did the general solution? Let me get to it. Let me just page back, I'll show you. Like this one, cos 3 theta. Then we get the answer, and then in the final step, I said it very, very repeatedly. You divide with that coefficient in front of the angle in the final step. Here it didn't make a difference. It was here. When we wrote the general solution. Then you divide, after you've written plus k times 180. Then you divide with 2, because remember that value influences the period of the graph, so it squishes the graph. It happens more times. Okay. So therefore it's important that you remember exactly that. Before you can divide with that 4, you have to write plus k times the period. So before I divide with that 4, I write plus k times 360. And then I divide all of them with 4 to get the final answer. So it's not very difficult, no? It's the same. We just didn't know that we can throw the sin and the sin away. And then this one, you can try it if you want. It's now the same. Let's see if you can get it right. Okay, threw away the tans. Simplify it to 2x equal to 60. Then you write plus k times 180. Then you divide with 2 to get the final answer. Okay, and then the last one, I didn't show them, I just gave them the sum. And I told them to go and think about it. So now this one has a problem because the angles are not the same and the functions are not the same. Okay. A page, book full. We're not going to do this now. So I'm just going to, but you can have a page. Okay. If I told you that you have to do something, you're not allowed to leave this question open. You have to try to get the angles the same, or you have to try to get the functions the same. Who can think? I won't throw you with something if you think wrong. But just try. Lepelu? Okay, but remember when we divided with cos, we divided with the cos and the angle. So we divided with cos like this. If it was cos theta equal to sin theta, we didn't actually just divide with cos. We divided with cos theta, and that became 1, and this one I divide with cos theta, and that became tan. So the whole thing, it's actually my mistake for the way that I talk, because I'm too lazy to say the theta every time. Okay, so it has to have the same angle there to do the division. Okay, that's why this one is a problem. This is not that type of haki. Okay, this is the cos of x minus 20. So remember, think of the graph. It means this is this graph translated 20 degrees to the right, and this is this graph, negative this graph translated 30 degrees to the left. So it's not like a distributive law that you can haki. Did we learn about... Kan jy sê sê van my? Tell me. Don't tell Lepelu. She won't know. Just say again. Is that what you said? So with a reference angle, you are on the right track. Now let me, do you want to try, Banana? Okay, let me give you just a small hint. I'm not going to do it now. You can go and play with it at home. Did we learn a way to change a cos to a sin or a sin to a cos? Did we or did we not? We did. What do we call those things? Not identities, co-functions. That's all I want to say. Okay. You can go and play with it. Right. It's not going to be in the test now. You can go and play with it. This is not even in the syllabus. Let's just get the juices flowing. That's what I want to do. Can I? May I? Okay. Moenie skrik vir die goggos nie. Okay. Sit. If that was theta and that was theta, what would you do? Shift tan 1, shift cos root 3 over 2. What's the secret to mathematics? So do the same thing. I just said shift tan 1, 45. Shift cos root 3 over 2, 30 degrees. Do you see now you've got two equations and two variables? Do you remember what we call those things? Simultaneous equations. Okay? So this one I took the 2 over, it's x plus y is 90. And this one I just got the x alone. 30 plus y. Fine? You all understand that? No? Nothing funny? Have I done something that you've never heard of in your entire life? No? Okay? Now I can put that one into this equation. So it's x. In the place of x I put 30 plus y. So it's 30 plus 2y. I took the 30 over. It's 60 divided by 2 is 30. And then what minus 30 is 30, 60. X is 60. Maklik. But you are scared of the gogo. I'm going to look for a gogo song to put in your test of Wednesday. Yeah, for sure. 5 marks. 50.